Now, another layer that you could add onto your plot is a smoother, and many times you want to do this just so you can get a sense of the overall trend in the data. So you might want to just get a general sense of as PM 2.5 increases, do we get more nocturnal symptoms? And so on the left-hand side here, this is the code down here at the bottom that I use. I have my original ggplot object, G, which just had the X and Y kind of aesthetics. I added my points to make the scatter plot, and then I added a smooth, the geom_smooth function, adds the little smoother, which is the blue line and the gray confidence bands. And so I use the defaults for the geom smooth, which is a low S smoother, which is generally fine, but you can see there's a lot of noise on the boundary. So on the left and right side of the smoother, the confidence intervals get very wide because it's flexible smoother, and there's a lot of noise in the boundaries because there's not much data there. So I'd rather something a little bit simpler than a low S smoother. I just want a linear regression line. And so that's less flexible, but it still gives me a sense of the trend. So here on the right-hand side, you can see I've remade the plot, and I've added the geom smooth, but I give it an option. I said method equals LM, and this will do a linear model instead of a low S smoother. And you can see that on the edges of the linear model, the uncertainty in the confidence bands is a lot smaller than it is for low S. And you see that generally speaking, there seems to be an increasing trend with PM 2.5 and nocturnal symptoms. So another layer we want to add is the facet. So this is the final layer to kind of reproduce that original simple plot that I made with ggplot. So here the facets are going to be determined by the BMI category. So I want to compare children who are normal weight and children who are overweight. So that's going to be two separate plots, but then I want to plot the same relationship in each one of those windows. So that's what creates the facet. And so I can add my facet with the facet underscore grid variable, and this variable uses a special notation which is separate, which has kind of a variable on the left hand side and a variable on the right hand side, and they're separated by this tilde. And so the variables that you specify in the facet function determine how the kind of separate plots are laid out on the screen. And so the number of plots will be equal to the number of levels of your factor. And so if I have two levels in my factor, I've got normal weight and overweight, then that will create two plots for me. If I were to, and so notice that I only have a single a factor variable that I want to separate on. So I'm not going to have a matrix of plots. I'm just going to have a single row of plots. And so I'm only going to have two plots because there's two categories in this BMI variable. If I had two variables, and I'll give an example of that later, so a variable on the left-hand side and the variable on the right-hand side, then the product of the number of factor levels is going to be the number of plots that you generate with the facets. So here I've added the facet grid function, and I also added the smoother with my LM. Notice that it doesn't really matter what kind of order you put these things in. You can add them in at any order you want. And notice I stuck the facet grid function in between the smooth and the point, and that was fine. It still generated the plot. So the facets are useful for kind of conditioning on a categorical variable, and you can see here that the normal weight children don't seem to have any relationship between PM 2.5 and nocturnal symptoms, whereas the overweight children appear to have a much stronger positive relationship. The last thing I'll mention is that you notice that the labels in each of the panels, I didn't actually label them by hand. The labels come from the levels of the factor variable that you conditioned on. So it's important that you use the factor variables in an intelligent way and to have intelligent labels on them, because the ggplot will take that information and automatically apply it to the labeling of your plots. And so in ggplot, in some sense, it's easier to modify your data and make sure that the metadata is specified appropriately, rather than to kind of plot things and then kind of modify the plot later. It's better to make sure all your data is kind of organized and labeled appropriately before you make the plot, because then that makes the plotting code much simpler. So once you've kind of made your plot, often you want to modify things like the axis labels and the titles and other kinds of kind of plot metadata. And so there are a number of functions for doing that. For the labels, there's the xlab function, the ylab function, and the ggtitle function. Those are all used to specify the x label, the y label, and the title. You can also use the labs function, which is a more general function that can be used to specify x, y labels or titles. It doesn't really matter what you use. Each of the geom functions, like the geom points and the geom smooth function, have options that you can specify to change things. So you can explore some of those options too if you don't like the defaults. There are some things that only make sense kind of in a global thing, and globally meaning for the whole plot, and so that the theme function is available for that. So this might specify kind of the basic colors, the background colors, or here, for example, the position of the legend. And you can use the theme function to specify these options. And then finally, there are some general themes that are built in that kind of control a lot of different elements of the plot. So you can specify to kind of set many options at once. And basically, the theme underscore gray is kind of the default theme, and it gives you the gray background with the white line, the white grid lines. The theme BW for black and white is a kind of more stark, a plainer theme if you don't like the gray background. So I'll talk a little bit about kind of modifying some of the features of the aesthetics. So for example, sometimes you might want to change the colors of the points. If you don't like the black points, or if you don't like them to be solid, you want them to be transparent. You can, on the left-hand side, I've modified my basic scatter plot of PM2.5 and nocturnal symptoms by doing two things. One is I've made the color steel blue. I've increased the size of the points to be 4. The default is 1. And I've changed the alpha transparency to be a half rather than solid. And so now you can see that there's blue points that are steel blue. They're somewhat transparent, and they're a lot bigger than they were before. The important thing to realize that I placed these options in the geom point function, and each one of these options, the color, the size, the alpha, have all been set to be a constant. And so the constants basically are for the are not actually aesthetics. They're just options for putting the points on the page. On the right hand side here, you can see that the plot looks similar, but there's 2 colors now, and each of the colors corresponds to whether the child is overweight or normal weight. And so now you can see when I call geom underscore point, rather than say just color equals BMI cat, which would assign the category of BMI to be a different color, I have to wrap it in this AES function, which stands for aesthetics. So now, rather than specify color as a constant, so like steel blue, the color has been assigned to a data variable. And so it's very important that you know the distinction between assigning color to be a constant like black or white or blue, and assigning color to be the value of a variable. So when you assign color to be the value of a variable, what happens is that all the points are split apart, and each set of points is kind of assigned a different color, and then they're put back on the page along with this legend on the right-hand side. But then outside of the AES function, I still have my size equals 4 and my alpha equals 1/2. So those are unchanged from the left-hand plot, so that the points are still bigger and the transparency is still a half. And so it's important. So the key thing to remember here is that there's a difference between assigning a aesthetic value to be a constant and assigning aesthetic to be correspond with a variable, a data variable. If you want it to be a constant, you can just specify it in the geom point function directly. If you want it to be assigned to a data variable, then you have to wrap it in this AES function. You can modify the labels with the labs function. So the labs function I've called a few different times. I've added on to my basic plot. So the G object, remember, it's just the data frame plus the X and Y coordinates. Here I've added geom point function, and I've assigned the color variable to BMI category. So now the 2 different BMI categories are in 2 different colors. The labels, I set the title to be max cohort because that's where the data come from. This is the max study. I've set the X label to be this expression, which is log PM2.5, and I used the mathematical annotation that we talked about previously to get that PM2.5, that 2.5 subscript on there. And then I set the Y label to just be nocturnal symptoms. So now it looks a little bit cleaner. The plot has kind of more appropriate labels on it. I can also customize the smoother if I want to. So now I'm going to modify the options to the geom smooth function. So here, all I've done is I add an option to say size equals 4. So I made the line a little bit thicker, and I made the line type to be equal 3. So the 3 that just means a dotted line instead of a solid line. I still use method equals LM, so I want a regression line. And I turned off the confidence interval so that's a little bit more clear to see, so I say SE equals false. So these are all options that you can add to the geom smooth function if you don't like the defaults. So Another thing you can do is just change the overall theme. So the default theme, you look in the previous slide here, you can see that there's a gray background with this kind of white grid lines. So there's solid, kind of thicker white lines for kind of larger kind of intervals, and then there's kind of thinner white lines for smaller intervals. If you don't like that background, you can change it to the kind of a more basic black and white background. So this is the theme_BW theme. And another thing you can see I've changed here is I've changed the font. So the default font is going to be something like Helvetica, but I've changed it to be a Times font. So now you can see that it's a serif font as opposed to sans serif, and it looks like and it uses the Times font to do the labels, to do the legend, and also the axis tick. So you can see the numbers and the axis are all in the Times font. So the various theme functions can be used to modify these elements of the plot.